Hello students, welcome back to your YouTube channel Mathematics for Everyone. In this video, we are starting differentiation of class 12th mathematics. So first of all, differentiability we define. Suppose f is a real function, f is a real function and C is a point in its domain. In its domain, then the derivative of then the derivative of function f at point C is defined by limit h approaches 0 fc plus h minus fc over h, provided this limit exists. Provided this limit exists. The derivative of f, the derivative of f at C is denoted by f dash C or d by dx fx at C. The function defined by the function the function's derivative defined by limit h approaches 0 fx plus h minus fx over h whenever the limit exists. Whenever the limit exists is defined to be the is defined to be the derivative of f, the derivative of f, which is denoted by f dash x or d by dx fx or if y is equal to fx, then by if y is equal to fx by dy over dx or y dash. The process of finding derivative of a function is called differentiation. If limit h approaches 0, fc plus h minus fc over h does not exist, then fx is not differentiable at x is equal to c at the point c. A function f is f is differentiable at a point c in its domain, if both left hand limit h approaches 0 negative f c plus h minus fc over h, and right limit h approaches 0 plus fc plus h minus fc over h are finite and equal. A function is said to be differentiable. A function f is said to be differentiable in an interval, in an closed interval a b, if it's differentiable at every point, if it is differentiable at every point of closed interval a b. Similarly, a function f is differentiable, at a point in closed interval AB if it is differentiable, if it is differentiable at every point of open interval AB. Then we take chain rule of differentiation. Chain rule of differentiation. Before starting this, just we want to revise whatever we have done in the 11th class. We have done the derivatives of sin x is cos x is minus sin x, tan x is secant square x, and cot x is minus cosecant square x. Derivative of secant x is secant x tan x, and derivative of cot x is minus cosecant x cot x. Similarly, we have already done product rule and quotient rule of differentiation in the previous class. Now we are taking chain rule. If f, g, h are functions of x, then derivative of d by dx f bracket g h x raised power n is equal to, first of all we take the derivative of outermost function is f, second outermost is g, third outermost is h, and the fourth innermost is x raised power n. We shall take derivative in the, first of all we take derivative of outermost f dash g h x raised power n into, then we take derivative of g function g dash h x raised power n, then derivative of h dash x raised power n, then the derivative of n x raised power n is n x raised power n minus 1. So in this way we'll have to identify the outermost function, second outermost, third outermost, and so on. And then we shall take the derivative and we shall multiply this. Now we are taking questions based on chain rule of differentiation. First question, differentiate the functions with respect to x. First question is sin x square plus 5. Solution d by dx of sin x square plus 5. Now in this case, we can see that there are two functions. Outermost function is sin, then the second function is x square plus 5. Derivative of sin is cos. When we take derivative of sin, the next inner function remains as it is. Sin is cos, and derivative of x square plus 5 is 2x. plus 0. So this is 2x cos x square plus 5. This is answer. Second question. Cos of sin x. Cos of sin x. Solution d by dx cos of sin x. Now we have three functions. Outermost is cos, second outermost is sin, and third is x. First of all, we take derivative of cos. This is minus sin of sin x. Then first of all this, then sin, then x. That of sin is cos x, that of x is 1. So this is minus cos x sin of sin x. This is the answer. Third question. Sin of ax plus b. Solution d by dx sin of ax plus b. There are two functions. First is sin and another is ax plus b. Derivative of sin is cos of ax plus b, and that of ax plus b is x is 1, a into 1, b is 0. So this is a cos ax plus b. Answer. Fourth question. Secant of tan square root x. Solution d by dx secant of tan square root x. There are again three functions. First is secant, another is tan, then the last one is square root x. Derivative of secant is secant of tan square root x into tan of tan square root x. Then the derivative of tan is secant square root x, and derivative of square root x is 1 over into 1 over 2 square root x. So this is the answer. Next, fifth question. Sin of ax plus b over cos of cx plus d. Solution d by dx sin of ax plus b over cos of cx plus d. Now we shall apply quotient rule. Quotient rule is d by dx u over v when v is not equal to 0, v into derivative of u minus u into derivative of v over v square. Therefore is equal to, here u is sin x plus b, v is cos x, cx plus d. This is d. So this is cos into cx plus d, derivative of sin is cos ax plus b, and that of x plus b is a. Derivative of b is 0 and that of x is 1 minus sin ax plus b into derivative of cos ax plus b is minus sin cx plus d into c over cos square cx plus d. So this will be cos ax plus b cos cx plus d into a, then plus c sin ax plus b sin cx plus d over cos square cx plus d. Then we take next sixth question. Cos of x cube into sin square x square. Solution d by dx cos x cube into sin square x square. Here we shall apply product rule of differentiation. As we have already done, product rule is d by dx ub is equal to u into derivative of v plus v into derivative of u. So this is cos x cube into derivative of sin square. There are three functions. First is square, another is sin, third is x square. First of all, we take derivative of square. So derivative of sin square x square is sin square is 2 sin x square into derivative of sin is cos x square. Then derivative of cos is, x square is 2x plus sin square x square into. Now in case of derivative of cos x cube, there are two functions. One is cos and another is x cube. That of cos is minus sin x cube. Then into derivative of x cube is 3x square. So this is equal to 4x sin x square cos x square cos x cube minus 3x square sin square x square into sin x cube. This is the answer. And next seventh question. 2 square root of cot x square. Solution d by dx 2 square root of cos x square. There are three functions. One is square root outermost, second is this is cot. Second is cot, third is x square. So first of all, 2 into derivative of square root is 1 over 2 into square root of cot x square into derivative of cot is minus cosecant square x square. Then derivative of x square is 2x. So again the outermost function is square root. First of all, we take derivative of square root, which is 1 over 2 square root of cot x square. Then into derivative second function is cot. Derivative of cot is minus cosecant square x square. Then derivative of x square is 2x. This cancelled. So this is 2x minus 2x cosecant square x square over square root of cot x square. So that's all. We shall take more problems relating to chain rule in the next video, and also we shall take the question in which we shall consider the existence of derivative of a function at some point. So please don't forget to like, share, comment, and subscribe to your YouTube channel Mathematics for Everyone. Thank you. See you in the next video.